One voice can change the world. The Global Health Connections International's focus is to make a difference in the lives of the students who's interested in the science, technology, engineering, and math program. With the partnership of NCCU, UNC, A&T, and other foundations, students ambassadors took students of James E. Shepard International Baccalaureate School of Durham to the campus of UNC as the triangle was visited by the first African American astronaut to walk on the moon. Dr. Bernard Harris, a retired NASA medical doctor, came to explain his experience and knowledge of being in outer space. He sat in the conference room and explained the process of return to Earth. Students are amazed as we listened in.
So it takes a little bit longer to come back. When we decide that we're coming home and we burn the orbit engines, it takes about 45 minutes to an hour or something like that. Yeah.
Why does it take longer to get back?
So if
It's probably
you...
because you're using those powers.
Well, it's not only that, but it's the maneuvers that we have to do, right? So if we're going to, you know, if let's say that's the Cape right there, that's where we land. That's where we take off and land. That's in Florida, right? So what we'll do in orbit, in order for us to stay in orbit around the Earth, we have to reach a speed in order to keep us like in orbit, like a satellite orbiting around the Earth. And so the higher the speed, the higher the orbit, and it's something called orbital mechanics, and that's what we learned as an astronaut. And so it's just the physics of how you keep bodies moving in space. So when we come home, if we have to speed up to stay in orbit around the Earth, what do you think we have to do to come home?
Slow down.
Slow down. So what we'll do is I'll use this as my little spaceship. So if that's Earth, and we're going around in this direction just like this, then what we do is we'll flip the vehicle around and maneuver the engines now at the back of the vehicle, and we'll burn the engines in the direction in which we're going. What do you think happens then? It slows us down. And as it slows us down, that all takes some time. Oh, by the way, did I tell you the speed in which we're going around the Earth? 17,500 miles an hour. So we are going around every hour and a half. Every 90 minutes we're going around the Earth. Wow. So here we go. So here's Florida. So we got land. So we're going around, keep going around. And then we'll burn the engines. That slows us down. And now the Earth's gravity begins to pull us toward the Earth. And as it pulls us toward the Earth, we'll flip the vehicle around so that we can be, you know, facing in the right direction and go back. And we come in through the atmosphere. As we come in through the atmosphere and we hit the atmosphere, you probably know what happens then, right?
And pressure.
You get the pressure, so we hit the atmosphere. The air is moving so quickly around the vehicle that the air around the vehicle actually catches on fire. So if you're looking at us from the ground, you can't see the shuttle. All you see is a ball of fire that goes completely around the vehicle. Like a meteor, exactly, like a falling star. That's what we look like. So as we come through, we're slowing down, and in order for us to slow down even more, we have to do these long S-turns as we cut through the atmosphere and we get closer and closer. And so we'll go from 17,500 miles an hour and land at 219 miles an hour. Ooh. So it's taking a lot, all in less than an hour.